Welcome back, everyone. This is the second part of the lesson, kicks and their occurrences. Through the first part, we gave an introduction to kicks and talked about the occurrences and causes of kicks. Well, today we'll be talking about some indicators of kicks and what should be done in case of a kick. And then finally, we'll be talking about how to kill a kick. Alright, so let's get started with the lesson. Well, one of the primary indicators is that the flow rate increases. This is when the mud flow rate increases when returning back to the surface. So when the mud rate increases, it's a given that the formation influx is being entering the wellbore and it's pushing the mud with an extra force. So that's how the flow rate increases, because the influx pushes the mud. Okay, so another primary indicator is when the pit volume increases. Pits are storage tanks for mud and they are located at the surface. Well, you see, this is the wellbore, and when the mud returns to the surface, it will be stored in the mud pits before it's circulated back into the wellbore. So, just to clarify more, the mud actually goes through the shale shakers in order to remove the cuttings, and then it will be directed to the mud pits. But that's another topic. However, the level of mud in those pits should always be the same, which means the same volume of mud comes into the pit and the same volume leaves the pit to the mud pumps in order to circulate it into the wellbore again. So any increase in volume of mud in those pits, as you can see from here that the level of mud has increased, this is an indication that somewhere in the wellbore the formation influx is entering the wellbore. So it's just that simple. When you see that the mud pit level has increased, you should know immediately that a kick is occurring. So the third primary indicator is flowing well with pumps off. Well, this is almost the same as flow rate increases because the formation influx will exert some sort of pressure on the mud and it will make it to circulate even when the pumps are shut down. So that's all for the primary indicators. Let's move on to the secondary indicators. Well, one of the secondary indicators is that the string weight changes. This one is a little bit complicated, so you might want to pay a lot of attention. Look, imagine this is the wellbore, and this is the drill string. When you put an object into a fluid, then the fluid will exert an opposite force on that object. And this force is called the buoyant force, which is represented by Fb. Well, this buoyant force increases and decreases with respect to the fluid density. The greater the density, the greater the buoyant force. They have a proportional relationship with each other. Well, another thing that I want to mention before connecting all this to the kicks is that the buoyant force tends to decrease the weight of the object. Alright, let's get back to the figure. Imagine a kick is occurring right now, which means the influx is contaminated with mud. Well, this contamination, as we talked about in the first part of this lesson, this contamination will lower the density of mud. And when the density is lowered, the buoyant force will decrease because, remember, they have a proportional relationship with each other. In result, the drill string weight will also decrease. Therefore, when the drill string weight changes, usually decreases, you have to know immediately that a kick is occurring. Well, I hope I made it clear for you because this one is complicated, I know. Okay, so the second one is drilling break. Well, this is a sudden and abrupt increase in rate of penetration. And this usually happens when we drill through a formation that is porous, permeable, and contains fluids. And that's the whole reason that when a drilling break happens, you have to know that a kick is ensuing. Well, the last secondary indicator is cut mud weight. Well, this is a decrease in mud weight due to the formation influx entering the wellbore. Well, therefore, when the mud weight or density is suddenly decreased, you have to assume that somewhere in the open well, the formation influx is entering the wellbore, and it's making the mud lighter. So, once you observe the sudden decrease in mud density, you have to take the necessary precautions to take control of the situation. And in the next slide, we'll talk about these precautions and procedures. Alright then. So, if one of the indicators of a kick occurring has been observed, this procedure must be immediately followed. Well, first, stop the drilling operation and shut down the pumps. You see, this first precaution is taken in order to prevent the well from further damage. Once you've done this, then check if there's a flue from the top of the well, or check for another indication of kicks. Well, if fluids are coming out of the well, then close the BOP to shut in the well. Well, in other words, when we say if fluids are coming out of the well, means once you confirmed that a kick is actually happening, is actually occurring, is taking place, then you have to close the BOP. Once you close the BOP, the well will be shut in. Okay, so once you shut in the well, the next take readings to stabilize the drill pipe and casing pressure. Well, this one is done in order to save them from any damage that could be caused by the kick. And those readings, the readings for stabilizing the drill pipe, drill pipe is another word for drill string. And the casing pressure, those readings are taken by using the gauge pressure at the wellhead. There are some valves that are used for measuring the gauge pressure and some other readings inside the wellbore. Well, and then specify the depth where the kick is occurring. The depth at which the kick is occurring is usually determined through calculations or well logging, but usually well logging is used for determining this depth at which the kick is occurring. And then prepare a weighted mud, also called kill mud, in accordance to the severity of kick. Well, for example, if the kick is very severe, then you have to prepare a mud that its weight is very high so that it can be able to kill this kick. And then finally, use this kill mud or weighted mud to kill the kick. And let's talk about those two methods in which we can kill a kick. Well, the first method is called weight and weight method, which is also called engineer's method. And the second one is called the driller's method. Well, as you can see, they're pretty much the same, but in driller's method, we use two circulations to get rid of the formation influx that has entered the wellbore. Well, you see, in weight and weight method, first, once a kick is detected, the well is shut in, and then a weighted mud or kill mud is prepared in order to kill the kick with. So the kill mud is circulated into the wellbore through a kill valve on the BOP. You see, a kill valve is a valve on the BOP that is mainly used for injecting fluids into the wellbore. So kill mud is no exception. In order to kill the kick, the kill mud is circulated or is injected into the wellbore through the kill valve. We'll talk more about this valve on the next slide. So this kill mud is circulated until the rest of the contaminated mud is replaced with the kill mud. You see, we want to get rid of the contaminated mud and replace this contaminated mud with the kill mud that has the ability to restrain the formation influx from entering the wellbore. And then this contaminated mud will be directed to a separator. It will be directed through a choke manifold. And this choke manifold is also on the BOP. We'll talk more about it later. This mud will be directed to a separator in which the influx can be separated from the mud so that the mud can be recycled, can be used again. Alright, so in driller's method, you see again, once a kick is detected, the well is shut in, and then a weighted mud or kill mud is prepared. But instead of injecting this weighted mud into the well bore, we do another step in which the contaminated mud is continuously circulated until most of the influx is displaced through the choke manifold on the BOP. So usually we take this method, the driller's method, to reduce the pressure of the formation to an extent. So if you anticipate that there's a lot of formation influx, then you might want to take this way to kill the kick. And then once the formation influx is displaced, then the next step, the kill mud is circulated into the well bore in order to replace it with the contaminated mud. And then finally, the contaminated mud will be directed to the separator so that the influx and the mud can be separated from each other. Okay, so take a look at this figure. Well, this is the BOP, the blowout preventer, and this is the kill valve. And here is the choke manifold, and this is the separator. Well, once a kick is detected, then the well is shut in through the BOP, and then a weighted mud is prepared and is injected into the well bore through the kill valve. Then this weighted mud is continuously circulated through the well bore in order to get rid of the contaminated mud. And then the contaminated mud is discharged from the well through the choke manifold. And then this contaminated mud is directed to a separator where this influx and the mud can be separated from each other so that the mud can be recycled, as you can see from here. And the weighted mud inside the well bore, because it has a greater density, a greater weight, then it will be able to restrain the formation fluids from entering the well bore. And thus, a kick is killed. Alright, so this is the end of our lesson. I hope I've been able to give you all the information you needed. And if you have any question regarding to the things we talked about in this lesson, then feel free to leave your question in a comment and I'll be happy to answer it. Thank you very much for being with me so far. Stay safe.